Hello everyone. The papers we will discuss today are the European Roadmap towards Fusion Electricity, Chapter 9, Cost of Electricity. For fusion electricity to compete on the market, it is important to keep the cost of electricity as low as possible. The cost is largely driven by three factors. 1. The cost of the fuel. 2. The operational cost. And 3. The cost of the infrastructure. A fusion reactor needs only a very limited amount of fuel at negligible cost. However, the operational costs, which are related to the availability of the plant and the infrastructure, are costly, and therefore much attention is devoted to find ways to lower these costs. In the previous section, it was already argued the remote maintenance scheme should be optimized such that the time needed for replacement or repair are minimized, such that the plant has a higher ability. Novel developments that certainly will have a positive effect on the cost are additive manufacturing of complex components and virtual engineering, in which virtual components are tested in a computer. High-temperature superconductors can be operated at a somewhat higher temperature, 20 Kelvin, instead of 4 Kelvin, to reduce the cost of cryogenic cooling. Increasing the magnetic field has the drawback that the stainless steel support structure, which is needed to keep the coils in shape and compensate the out-of-plan force, will come more bulky. A simulation for the demo coils has led to the conclusion that an increase in the magnetic field strength from 12 Tesla to 18 Tesla would necessitate an increase of the radial depth of the stainless steel support structure from about 1 meter to about 2.5 meter. This needs to be added to the 1.7 meter radial built at the high field side, which was quoted in the section on tritium breeding. A recent optimization study, including safety, tritium breeding, remote maintenance, etc., based on parameter variations in a system code, has come to conclusion that a cost optimum is reached for a reactor with a major radius close to 9 meter. The maximum field on the central solenoid in these studies was limited to 13 Tesla. Thanks for listening to the end of today's show.